Hello and welcome to our lesson on vectors for our trigonometry class. This is going to be section 9.4 from the text. This lesson is all things vectors. So you'll notice I've got 6 red boxes here. These are all of the formulas you're going to need for this section. Let's get started. This is the standard form of a vector. And what I want you to notice is that there's actually 2 forms written here. There is AI plus BJ form, and also this that kind of looks like an ordered pair, but the parentheses are arrow symbols. These mean the same thing. AI plus BJ and A comma B, these are both standard form of a vector, just 2 different notations. Okay, the next formula here is for finding a vector if you know the initial point and the terminal point. So I'm going to call this the 2-point formula, for lack of a better name. And you have to have 2 points in order to find the vector with this formula. So to point out what is important, the x2 and the y2, that would be your terminal point, and the x1, y1 would be the initial point. And here order does matter. Also, you're going to notice both formats again, both notations. This would be the AI plus BJ formula, and this would be A comma B, both notations represented here. Next formula is for finding the magnitude of a vector. Magnitude could also represent the length of the vector. And at the bottom here, we have the direction angle. And the reason I jumped to that is because every vector has a magnitude and a direction. That's kind of important to know. Vectors have a magnitude, which is a length or a speed, something like that, and then the direction that it's heading in. All right, next formula. We have the formula for a unit vector. And what a unit vector is, that is a vector that has the same direction as a given vector, but it only has a length of 1 unit. A unit vector is unique. It has a length of 1 unit. And for the final formula here, we have what I call the M and D formula. And this formula is used to find the standard form of a vector if you know its magnitude and direction angle. So I call it the M and D formula because you need the magnitude and the direction to actually find the vector with this formula. And that's going to do it for the formulas. So the next thing to do is to jump into the examples. And the first couple of examples that we're going to deal with have to do with graphing. And so what I'm going to do is I'm going to turn on my graph paper. The first example, it gives us all of these vectors over here, u, v, and w, and it says to find v plus w. So we're going to add vectors v and w using the tip to tail method. Notice that vector v has a direction of 0 degrees. It's pointing in the direction of 0 degrees. It has a magnitude of 5. So we're going to start here and go over 1, 2, 3, 4, 5. And this represents vector v. Now to add vector w using the tip to tail method, we're going to start at the tip of v and attach the tail of w. Now W is a vector that goes over 2, up 5. So from the tip of V, we're going to go over 2 and up 1, 2, 3, 4, 5, and that'll give us the tip of W. Okay, so there's vector W sketched out. And this is how you're going to add vectors graphically. The way that you represent V plus W is you start at your starting point here, which is the tail of V, and you're going to go to the tip of W. And so that would be vector V plus W. That's how you add vectors. And the next example wants us to find 3V. This is going to do what we call a scalar multiplication. So here we go. Vector V has a length of 5. So we're going to go 1, 2, 3, 4, 5. That would be 1V. 1, 2, 3, 4, 5, 2V. 1, 2, 3, 4, 5, 3V. So if I erase these in between and connect the dots here, this would represent 3V. It's the same direction as vector V, but the magnitude has been tripled, 3 times its length. And that's the two most common things that you're going to need to know how to do with vectors, which is vector addition and then scalar multiplication. Next example, we're going to be given a vector has initial point P, -2, -1, and terminal point Q, 6, -2, and the instructions say find the standard form of the vector. Now, as far as I'm concerned, you can write it as AI plus BJ, or you can use this ordered pair notation. Whichever one they ask for is the one that you need to use. I'm going to stick with the AI plus BJ notation. Just know that this other notation exists, and if they ask for it, you're going to need to give that. All right, so here we go. We're going to be using the 2-point formula because we were given 2 points. And remember I said that the initial point is x1, y1, and the terminal point is x2, y2. And then we can plug into our 2-point formula to find the vector. That was x2 minus x1, and that's going to be the I component of the vector, plus y2 minus y1, and that'll be the j component of the vector. 6 plus 2 is 8i. -2 plus 1 is -1j. And if you want to put the 1, you can. If you don't want to put the 1, you don't have to. I'm not going to put it. I don't like to put things that are not necessary. And for the next example, we're going to be given vector v. They're actually going to give me vector v. -2i plus 3j. And the instructions say find its magnitude. Something important that you need to know is that the symbol for magnitude looks a lot like double absolute value. So when you see something that has this double absolute value look to it, it doesn't mean that it's really positive. It means find the magnitude of the vector. And so that formula was the square root of a squared plus b squared. And here we can see the value of a and b. So that's going to be -2 squared plus 3 squared, which is 4 plus 9, which is square root of 13. Now you do want to leave that exact unless they ask for a decimal approximation. If it says give the exact value, the answer is square root of 13. Otherwise, you'll need to use your calculator and round that off to how many places they ask for. Next example. Here we're going to be given a couple of vectors. Vector v is 3I minus 5j. Vector w is negative 2I plus 3j. And they ask us to find 2v plus 3w. And so all this is really, it's plug and play. So we're going to have 2 times v, which is 3I minus 5j, plus 3 times w, negative 2I plus 3j. And then we're going to use the distributive property and CLT, combine like terms. That's going to give us 6I minus 10j minus 6I. I have a bad feeling about this. Plus 9j. And if you look at my I terms, they're going to cancel. No i's left. Negative 10j plus 9j, that is negative 1j. Or you could say negative j. And that is the answer for that problem. Next example. Here we're going to be given vector v is negative 5I plus 12j. And the instructions say find the unit vector. So the unit vector is v over the magnitude of v, which is going to be negative 5I plus 12j, divided by its magnitude, which is negative 5 squared plus 12 squared. And that's going to give us negative 5I plus 12j divided by the square root of 25 plus 144 is 169. And I believe that does square root nicely. Now you do need to separate this into each component. The square root of 169 is 13, so that's going to be negative 5/13 I. That is the I component of the vector. Plus 12 over 13 j, and that is the j component of the vector. And there is the unit vector done. All right, next example. Here they give us the magnitude of vector v is 25, and alpha, which they're calling the direction angle, is given to be 330 degrees. And it says write vector v in the form of ai plus bj. And that means they want us to write the vector in standard form. So we're going to be using the M&D formula, which says we're going to take the magnitude times cosine of the direction angle I plus sine of the direction angle J. All right, so if I distribute the 25, that's going to give me 25 cosine of 330 degrees. Whatever that is, that's going to be my value of A. That'll be my AI. And then 25 sine of 330 degrees. And whatever that is, that'll be my B. J. That'll be the J component of the vector. And to calculate those values, instead of using the unit circle and finding the X coordinate and the y coordinate at 330, I'm going to use the calculator, and we're going to do 25 cosine of 330 degrees, and that's going to be 25 square root of 3 over 2. That is the exact value. So for vector v, that's going to be 25 square root of 3 over 2. That'll be the I component of the vector. And then if we back up and delete and do the sign, negative 25 over 2, negative 25 over 2 will be the j component of the vector. And there's our answer. That is the vector in standard form, ai plus bj. I'd like to give you a little way that you can check and see if you screwed something up here. So notice the direction angle, which is 330 degrees, is in quadrant 4. 330 degrees is in quadrant 4. So if I graph this vector using the origin as the starting point, notice that my A value is positive and my B value is negative. So that would mean that I would go over so many A and then down so many B. And that would get us to the end point of the vector. So the vector ends up in the same quadrant as the direction angle, which it should. All right, next example. Here they're going to give me vector v is 4i minus 2j, and they ask me to find the direction angle. And so what I'm going to do, they don't ask for it, but just for fun, we're going to find the magnitude and the direction, okay? We're going to find both of those pieces. So the magnitude is not that bad. That's the square root of a squared plus b squared, which is going to be the square root of 16 plus 4, which is 20. And that will actually simplify. 4 times 5 is 20. That'll reduce to 2 square root of 5. And you do want to write that in simplest radical form. That is the exact value of the magnitude. The direction angle is the inverse tangent of b over a. Now, if you think about it real quick, if we were to graph this vector, we would go over 4 and down 2. And so we know that our direction angle is going to be an angle that ends up in quadrant 4. It's going to be bigger than 270, less than 360. So when we pull up our calculator to calculate the inverse tangent of negative 2 over 4, which, by the way, reduces, if you want to reduce it, that is going to be the inverse tangent of negative half. I want that to be in degrees. And so I'm already in degree mode. We're going to do inverse tangent of negative 0.5. And I'm using 0.5. It's equivalent to negative 1/2. That doesn't matter. Equals. Notice that gives me negative 26 point and some change here. So let's assume that they want us to round to the nearest tenth, which would be negative 26.6 degrees. And that is definitely a quadrant 4 angle because negative angles go clockwise and 26.6 is acute. However, I want the positive equivalent to that. So what we're going to do to get the positive equivalent to that is we're going to add 360. And I hope that makes sense to you. If I'm in quadrant 4 and I want to go around and return to the same location, I need to make a full circle. And so that's why we add 360. So pulling up the calculator again, we simply need to add 360 to that to get the equivalent positive angle, 333.4 degrees. And that is the answer they actually ask for. That is the direction angle of this vector. I believe that is all of the examples that I had set to cover in this section. Okay, so anything that you're going to need to know how to do on your homework or in this section, I think I covered an example of that. If I missed anything, or if you have any questions on any of the examples I did, please leave that in the comment section below, or remember you can also text me. And thanks for watching.